Hello everyone. So we are starting a new unit today the unit is called stoichiometry. Before we can start on stoichiometry, there is going to be some background information. Here is the digital notebook for this unit. Make sure you put your name, the table of contents. I do not currently have the dates on there, but now that you can see it, there are dates, and I'll show you how the pacing guide for that and when the test will be. There is also a slide here as an intro into moles and what we're going to be talking about. So I'm going to kind of go over this worksheet with you right quick. You should already have this answered, but I want to make sure you understand. So when you buy eggs, they typically come in a dozen. Well, we know a dozen eggs is 12 eggs, but that counts as 12 no matter what you're talking about. If I have a dozen pencils, I have 12 pencils. If I have a dozen pieces of chocolate, I have 12 pieces of chocolate. So it doesn't necessarily just talk about eggs, but it's a certain amount. Kind of like paper. Paper is not packaged by the dozen, but by a ream. A ream of paper has 500 sheets. Why is it useful to use units like dozens or ream? So I want you to think about why there's really no wrong answer. Why do you think people use those terms? And then what determines how many items should make up a particular unit? Same thing there, just type what you think. But just to kind of give you an idea, if I bought a dozen pieces of paper, that's not going to last me very long. That's 12 sheets of paper. It'll last me maybe a day. If I'm making copies, not even that. So that's why it doesn't come in a dozen. It comes in a ream, 500 sheets. It'll last a little bit longer. So what do you think determines how many items make up a particular unit? So as we know, a dozen represents 12. I have decided to make a new counting unit. I'm calling this unit an owl. So I have 4 items. So 4 is going to be the number in an owl. So if I have an owl of oranges, I have 4 oranges. If I have an owl of pencils, I have 4 pencils. If I have 2 owls of oranges, I will have 2 times 4, which is 8 oranges. If I have 4 owls of chocolate, I will have 4 times 4, which is 16 pieces of chocolate. If I have half an owl of pencils, I will only have 2 pencils because I'm taking half of 4 since we know 1 owl is 4. So that's just to kind of give you an idea. And you might be thinking, what does this have to do with anything in chemistry? Well, that brings me to the mole. So the goal for this section is molar mass. Well, that's your topic, sorry. Your goal. I can explain what a mole is and calculate the molar mass. So what is a mole? You need to write mole down, underline it, highlight it, but it is an amount of a substance, and it's a unit of measurement specific to chemistry. You'll also see it written as MOLE or mole. The abbreviation can also be MOL. I know that's just taking the E off and that's not really an abbreviation, but it is written like that. And then in some instances, you'll see it as the letter N. Okay, the mole is like a dozen. So we've already talked about how a dozen is 12. Well, the mole is also a very specific number and does not change. It is Avogadro's number, which is the number of particles in 1 mole. And that is 6.02 times 10 to the 23rd. So every time I have 1 mole of something, I have 6.02 times 10 to the 23rd particles. If I have 1 mole of salt, I have 6.022 times 10 to the 23rd particles of salt. If I have 1 mole of chocolate, that means I have 6.022 times 10 to the 23rd particles that makes up chocolate. So how is it used in chemistry? Well, elements, as we know, are made up of particles. And just like we said, 1 mole of anything is the 6.02 times to the 23rd particle. Okay, so how is that related to the molar mass? So 1 mole of each substance has a molar mass or a specific weight. It's the same as the atomic mass, but it's only in grams per mole instead of the mass being the AMUs. So 1 mole of sodium or Na. If I look at the periodic table, look at Na. It's going to be this bigger number right here, 22.99. So if I have 1 mole of Na, that means I have 22.99 grams per mole. So that's telling you how many grams I have in 1 mole, or 6.022 particles is this many grams. So that's what that's saying. So 1 mole of carbon, I'll look at the periodic table, find carbon, it'll be the bigger number, so 12.011 grams per mole. One mole of lithium. So we look at the periodic table for lithium, look at the mass, 6.94. So our answer would be 6.94 grams per mole. Okay, how do we do this with compounds? So here, you'll find the mass for each element. So we'll do H, and we'll do O. So here, you first put how many of that element you have. So H2O, we have 2 H's. So you'll do 2 times what the mass of hydrogen is. So find hydrogen, 1.08008. You can round that to 1. So 2 times 1 equals 2. For oxygen, we only have 1 oxygen. So 1 times the mass, which is 15.999. We can round that to 16. 16. So 1 times 16 is 16. We add those two numbers up, so you'll do 2 plus 16 equals 18, and your unit's going to be grams per mole. That's the molar mass. So if we do that for NaCl, we have Na. We have 1 Na times the mass, which is 35.45. You can round that to 35. We have Cl, which equals 35. You have Cl. We only have 1 of them, so 1 times on the mass of Cl. Sorry, the mass of Na is not 35. That was Cl. Alright, so let's do Na again. So 1 times the mass of Na, which is 22.99 or 23, equals 23. So we'll do 23 plus 35. 23 plus 35 equals 58 grams per mole. So that's how you do the molar mass. You find the molar mass of a compound. All right, so in your digital notebook, you do have practice here. You need to find the molar mass of each of those compounds. I do give you space to work out here. If you want to work this out on paper and just type in the answer, that is fine. You can send me the pictures of your notes if you need to, because I know with these math problems, it is kind of harder to do it on the computer. So if you have questions about that, let me know, and I'll be happy to help, and I hope you have a great day.